for example 3, now I can see that I have all of my values are stacked on top of each other, the x's, the y's, and the constants, but they don't have the same coefficients. My x's don't have the same coefficients, and my y's don't have the same coefficients. So if I just add or subtract the equations, does it actually eliminate either variable? No, because they need to have matching coefficients. So what it wants us to do is multiply the second equation by 3 and then add the two equations together. So if I multiply the second equation by 3, then I'm going to say that I have 4x minus y is equal to 22. I need to multiply the left side by 3, and I need to multiply the right side by 3, remembering that we need to multiply every single term. So I have equation 1 is going to be 2x plus 3y is equal to 4, and equation 2 is going to be 12x minus 3y is equal to 66. Now I can add the two equations together. 2x and 12x is going to give me 14x, and 3y and negative 3y will cancel out, and 4 and 66 are going to give me 70, which means that x is going to equal 5. Now I can take that answer and put it back into either one of these. I'm going to put it back into the first one and say that 2 times 5 plus 3y is equal to 4, or 10 plus 3y equals 4. 3y is going to equal negative 6, and y is going to equal negative 2. So I have my solution of 5 and negative 2. And just like in all the other cases, I need to verify this. So I'm going to put it into equation 1. 2 times 5 plus 3 times negative 2 is equal to 4. 10 minus 6 is equal to 4. 4 is equal to 4, and that one works. Equation 2, I'm going to say that I'm always going to do it in my original form. 4 times 5 minus negative 2 is equal to 22. 20 plus 2 is equal to 22. And 22 is equal to 22, and that works. Now it wants us to try it by, instead of making the y's match, make the x's match. So it wants us to take the first equation and multiply it by a number which will eliminate x. Well, in order to make the first equation match the second equation, well, I need to multiply the first equation by 2 to get it that coefficient of 4. So I'm going to multiply all the terms in here by 2 and say that this is actually going to be 4x plus 6y is equal to 8. If I state that 4x plus 6y is equal to 8 and 4x minus y is equal to 22, then in this case, I'm going to have to actually subtract in order to cancel out the x's. So 4x and 4x will cancel out. 6 minus negative 1 is going to give me 7y, and 8 minus 22 is going to give me negative 14. Divide both sides by 7, and y is equal to negative 2, which matches what we got in the first case. Now I'm going to substitute back into one of the original equations. I'm going to do it for equation 1 in this case, and say that 2x plus 3 times negative 2 is equal to 4. 2x minus 6 is equal to 4. 2x is going to equal 10, and x is going to equal 5. And I get the solution of 5 and negative 2 again, because it doesn't matter which one I eliminate, I should still be able to solve it and get the exact same solution. For example 4, consider the system of equations 5a plus 3b is equal to 3, and 3a minus 7b is equal to 81. First thing we need to do is choose appropriate whole numbers to multiply each equation so that the system can be solved by eliminating b. Well, I can't just multiply one or the other equation in order to make it work, which means that in this case, I can eliminate by multiplying all of equation 1 by 7 and multiplying all of equation 2 by 3, because then my b's are going to have matching values or coefficients of 21. So my equation 1 is going to become 35a plus 21b is equal to 21. And my equation 2 is going to become 9a minus 21b is equal to 243. Now I can solve the system by eliminating b. If 35a plus 21b is equal to 21, and 9a minus 21b is equal to 243, then in order to cancel it out, I'm going to have to add them together because the b's have opposite signs. So I can say that 44a, the b's will cancel out, is going to equal 264. If that is equal to 264, then I divide both sides by 44, and a is equal to 6. Now I'm going to substitute that back into my first equation in its original form. 5 times 6 plus 3b is equal to 3. 30 plus 3b is equal to 3. And 3b is equal to negative 27, or b is equal to negative 9. So I have a solution of a is equal to 6, b is equal to 9. Let's verify these. For equation 1, 5 times 6 plus 3 times negative 9 is equal to 3. 30 minus 27 is equal to 3. 3 is equal to 3, and that one works. For equation 2, 3 times 6 minus 7 times negative 9 is equal to 81. 18 plus 63 is equal to 81. 81 equals 81, and that works. Now, if I need to do the same thing, but I wanted to solve for a instead, well, once again, 5 and 3, the lowest common multiple is going to be 15, which means I'm going to multiply the first equation. So I'm going to multiply the 5a plus 3b is equal to 3, multiply all of that by 3. I'm going to multiply my whole second equation, 3a minus 7b is equal to 81, by 5 to make the a's match. So I'm going to wind up with 15a plus 9b is equal to 9, and 15a minus 35b is equal to 405. So, when I'm eliminating these, because the signs are opposite, or sorry, the signs are the same, I'm going to subtract them to eliminate. So the a's are going to cancel out, and then I can take a look at the b's. Well, if I take 9 minus negative 35, it's the same as plus 35, I have 44b. And 9 minus 405 is going to give me negative 396. When I divide it, b is going to be negative 9, which makes sense because that was my original. And then I'm going to substitute the value of b in to check for a. So I'm going to say that 5a plus 3 times negative 9 is equal to 3. 5a minus 27 is equal to 3. 5a is going to equal 30. And a is going to equal 6. And I get the exact same solution I did in the previous case.